Good morning, everybody. How's everybody's Halloween? Are there big Halloween parties on campus? Sort of. Heard you guys talk about Pomona has one. Pittsburgh.
Yeah. Which. Yeah.
It's good to see you all again here in person. Let's see. Yeah, so it's time for us to get started. So we'll go ahead and get started. Before we do, though, real quick, I want to highlight, or I just want to mention, I had a bunch of handouts for us today, but the printer wasn't working. So we'll still going to go over those handouts, but it's probably extra useful for you to bring them up on your own computer. And so I'm going to switch my screen here over to the class repository here under week 9. And there's 4 different files that we were going to have printed out. It was going to be these 2 Python files right here, this bs4 underscore practice quiz, and these other 2 practice quizzes down here, the PDF files. So it'd be good to get those brought up here at the beginning. We'll talk about those in a second. I'm going to switch my screen back over here and start by talking about just a quick review of the homework. So those are all graded, if you haven't seen that. And then talk about what sort of our upcoming class schedule is going to be like and the material for today. So with the homeworks, out of 15 points, and so the average 11.6, median 14. So most students did pretty well on the homeworks, but there are a lot of students who got a lot of points knocked off for various reasons. Some of the main common mistakes, so one of the big ones, there were a lot of late submissions with this homework assignment. And so I want to caution you with this upcoming homework assignment that's due, due this coming Sunday, that we did do the vast majority of the homework in the video lectures on Wednesday last week. So you might be tempted to be putting off this coming assignment a little bit since there's a lot of it already done for you, but I definitely recommend against that especially any of these assignments where you're interacting with like the internet somehow, there's just lots and lots of ways that things can go wrong. And so if you're working at the last day of the assignment and something goes wrong, then there's not going to be any chance for an extension. You'll get the corresponding late penalties. Don't put off this coming assignment. Another really common mistake was not putting the actual images that you generated in the README file. I think this was a -3 point mistake. And 2 reasons. Well, I guess the main reason why this is important is that the purpose of these putting the assignments out on GitHub in these README files is so that other people can come see them, and you want to make it easy for them to see the things that you've done. So actually making the images visible where somebody can just look at it and easily see it. These last 2 issues, depending on exactly how people did things, you could get anywhere from -3 to -6 for each of these issues. But there are a lot of plots where you told me you were plotting something and you were actually plotting something else, or you only had one type of line in the plot when there's supposed to be multiple lines in the plot. yeah, I guess maybe before I ask if there's questions, so the overall grades still pretty high in this class, 93.3. About a month ago or so, the grades were hovering in like the 87 range, but I think over the last few weeks with various extra credit opportunities, that's bumped people's grades quite a bit. And on this assignment, a handful of people's grades went up quite a bit too. But any questions about the assignment or any of that? If you do have questions about like your individual grades, then I'd be happy to, if you think I made a mistake or want more clarification on something, I'd be happy to look at that one-on-one with everybody. Let's see, how's everybody's like just last week overall? Do you have, is it kind of midterms time again for people? Yeah. Is the second round of midterms like, so I'd say like normally it's the second round of midterms is harder for people than the first round, but maybe like the first round was maybe extra hard because it was like the first test you've taken in years maybe.
No, you're right, the second round is harder.
Second round's harder still? Yeah. Do you all feel like the, like, I don't know, professors are making classes extra hard this year compared to normal years? Or is like normal compared to normal years? Just hard transitioning. Yeah.
Is your class easier than usual or harder?
That's a good question. Is this class easier or harder or the same? Every year, based on like student feedback, I try to cut out some assignments that weren't, or that students found not as useful as other assignments. So there's certain things that get cut out that way. And then I add a few other things that like, oh, like half the class was made this error on this assignment. And so let's have a quiz before that tests that thing to make sure that you don't make that error on that assignment. So I've tried to make it like the same level of work level, adjusting that. But yeah, it's probably, I don't know. Yeah, so I think it's the same, whether students think it's the same or not, who knows, I don't know. And it's hard for you all to tell because you haven't taken it before. So overall, same number of assignments though, and same number of quizzes and everything. Any other questions about anything so far? Okay, so upcoming quizzes, we have the, so this Wednesday, so normally we have our quizzes on Monday, but this Wednesday we'll have the list comprehensions quiz that we were going to have last Monday. So I didn't want to have it just today as like, haven't seen me in a week and come back straight to a quiz and maybe you had questions or something that you wanted to ask. So Wednesday we'll have that list comprehensions quiz. And then there'll also be 2 more quizzes coming up. So this bs4 quiz, so it'll be a quiz on the beautiful soup material. And hopefully that preparing for that quiz will help make this homework a little bit easier, more understandable. And then I'm also putting up this exceptions quiz here because the practice quiz for both of these 2 quizzes is in this week's material. So we're going to talk about the material for both of these 2 quizzes right now, but we'll do the bs4 quiz first since you have the homework assignment related to that, and then we'll do this this exceptions quiz after that. And there's also not going to be a quiz on Thanksgiving week, so you get a little bit of a break there from quizzes. Any questions like schedule-wise? Yeah. That's the Monday before Thanksgiving. Probably, yeah.
When will we receive the practice quiz for the BS4?
Yeah, question is, when will you get the practice quiz for BS4? So the practice quiz is posted. We're going to go over that today. These two files right here are the practice quiz. So that's what we're going to go over here next. The printer in the math department is broken right now. So presumably that'll get fixed sometime today. And then I'll have copies of this, like physical, that Wednesday in class I'll pass out to everybody. And then, yeah, so this one down here, this one that just says quiz practice, the quiz practice bank, that's the exceptions quiz. And after we're done with BS4, we'll start on that quiz. Good questions so far. Any other just administrative questions before we dig into the material? Okay. So then I'm going to open up VS Code to this Python file right here, this BS4 practice quiz, and we're going to go over it. So normally the quiz files that I pass out are all PDF files, but this one it's just a Python file. And I've made it a Python file to make it as easy as possible for you all to be able to just run the file and see exactly like what the answers are going to be. This beautiful soup library, BS4, is not included in the standard Python library. And so because of that, you can't use the pythontutor.com to evaluate these problems. That if you tried to do that, it would tell you that beautiful soup or BS4 is not available and it can't import it. So when you're working on these problems, you'll have to actually do it in VS Code and see what happens. And like the other quizzes, there's 5 problems. If we scroll down to the bottom here real quick. And so each one of these things separated by this big comment line is a different problem. And the idea is that there's always just going to be a little bit of code at the top, and then calculating something about that code, and then printing out what the actual the result is. And then the purpose or the thing that you're supposed to do on each of these problems is just, if it were printed out, you'd write next to this print statement exactly what number or value is getting printed right here. Question?
The BS code is on the 10th line.
So if this file is not working for you, then probably this library needs to be installed. So with the pip install command. And if we'll just go ahead and run this real quick. And so here's the answers to the problems. It'll just look like a bunch of numbers. And today in class, we'll go over exactly how all these numbers are generated. And so you'll be ready to do that on the quiz. And preparing for this quiz, so what this quiz is about is just reinforcing your knowledge of CSS selectors and how they interact with the beautiful soup library, so that you'll be able to do well on the homework assignment. So my recommendation is that to do the studying for this quiz before doing all of the homework assignments. That this will help you on the homework assignments. But also conversely, working on the homework assignment will help you on this quiz. So at the top of this quiz file, there's a variable HTML, and it just contains some HTML code. And this HTML code is actually the same HTML code that we used on our CSS selector quiz way back at the beginning of class, maybe the second week of class. And there's another practice quiz 2 file. The HTML here is from one of the other practice quizzes from that one. So I'm not trying to trick you with this HTML. It should be hopefully straightforward and things that you've seen before. And then line 32 right here is just creating that soup object that we can do the selection with. And then everywhere, we're just using this soup.select function with some sort of CSS selector inside of here. And it's going to find all the corresponding matches up above for that CSS selector. So here, when we're looking just for the A, we have to go up here and find all of the A tags. And there's an A tag right here. And an A tag, let's see. There it is, an A tag right here. So there's this CSS selector right here. The CSS selector matches 2 different A tags. And so when we do the length of the tags, we'll get 2. I want to take a real quick look at the what this tags variable actually looks like though for a second. And so in order to do that, I'm going to enter in interactive mode with a -I right here. And so now I can do, just paste that in. And this tags is a list. So anytime you call the select operator here, you're just going to get a list out. And then each of these things right here, it's just printing the actual HTML, but this is another one of those soup objects that you can do the different manipulations on. So the very first 3 of these questions, what they're testing is just your CSS selector knowledge. Do you know what things are going to get selected by which CSS selectors, and then going up here into the HTML and finding that. So any questions about this first problem? Why this A selected two different things? Yeah.
So when we have the quiz, is it just going to be like this Python document printed on paper, and we need to write a problem to the bottom?
Yeah. So it'll be this. Yeah. So again, apologize that I don't have the printed out thing for you, but it'll be this. Exactly this document printed out on paper, and then just sort of between these 2 things is where you would write the, so the answers here is 2, so you just write a 2 right here, like next to each of these print statements. So here, again, the P span, when you have 2 CSS selectors that are right next to each other, separated by a space, this is going to go find all of the descendant span tags of a P tag. And so coming up here, we first find all the P tags because the P was the leftmost tag. There's a P tag right here and a P tag right here. And those are the only 2 P tags. And then we look inside both of those P tags for span tags, and we find this span tag right here. And if we scrolled over to the right, since VS Code doesn't display it, there's no other tags. They're all at the very beginning of the paragraph. And so here's an A, this one's a span. Span is the only one that matches. And so that's why it's 1 for problem 2. So again, really what these first problems are testing is just your knowledge of CSS selectors and what tags get extracted for those CSS selectors. This last one, again, the comma and the dot, the difference between those. The dot means that you're selecting a class, something that says class equals bold, and the comma is like an or. So the P here will find all the P tags, and then this dot bold will find all of anything that says class equals bold. So we have this P class equals bold, P right here, and then class equals bold. So there's 3 class equals bolds, this one, and this one. And then the 2 P tags, this one and this one. The important thing to note here is that this P tag right here matches both of the conditions. It matches the P condition and the class equals bold condition, but it's only going to get included once down in the results. So when I say tags P comma dot bold like this, and then list out the tags, there's 4 of those tags. There's this span tag right here, this span tag right here, this p tag right here, all matching the class equals bold, and then this p tag right here matching the p. This one here matches both of them, but it only gets included once. If you look down here, here's our p class equals bold, and it's only present once in this list. It's not present twice, even though it matches both parts of the CSS selector. So the principle there is that soup.select will always remove duplicate tags for you. Any questions about that? Okay. So I'm going to skip. We'll come back to this problem 4 here in a second, but I want to come down to this problem 5 here next, where it has, so here we're selecting P and we're selecting dot bold separately. So up here in problem 3, we're selecting P or dot bold in the same CSS selector. Down here, we're doing it separately. And if we look at the number of tags that we get this way, we'll copy and paste this down here. And now the length of tags is 5. It's 1 more. And that's because the length of tags 1, where we're looking for the P's, there's 2 P's in the problem. And so it finds both of those. And then we look for the bolds. There's 3 bolds. And so we get all 3. And even though there's the P class equals bold, so scroll up here, P class equals bold, this matches both of those 2 tags. But when we do those as 2 separate selections, they don't get removed. It doesn't remove the duplicates. So this in one select call removes the duplicates. This in 2 separate select calls does not remove the duplicates. And so in this case, we'll get the answer to problem 5 is 5 instead of 4 because it's counting the P and the dot bold twice. I think this is a common source of errors, both on the homework assignment and on this quiz, is that students will think you're doing one of these things, thinking that either the duplicates are getting removed or not getting removed, and so that throws off the results. So pay attention to this on your homework assignment, and pay attention to this on the quiz. Ready? So we haven't talked about problem 4 yet. Sorry.
So the answer problem. What do you mean by that's not what? Does it mean like it doesn't replace the previous one, or
so here when we have P comma dot bold like this, that P comma dot bold matches this class or this tag right here in 2 ways. The P part matches the P right here, and the dot bold matches the class equals bold. But when it's done with a single select statement will never return this same P tag twice. So that's what I mean by remove duplicates, that this is only going to get returned once inside of problem 3. But on problem 5, it's going to get returned twice because we have 2 distinct select calls. And if we look at the contents of tags 1 and tags 2, we can see here there's this P tag right here and this P tag right here, the same thing, so it's included in both of them. And when we add the 2 lists together, that's just normal Python list adding, and list adding in Python doesn't care about duplicates, and so it keeps it around. All right.
It was the bold that was the duplicate, right?
The particular duplicate is, so this, basically this entire line right here, this whole tag is the duplicate. And the reason it's a duplicate is because this P right here matches this P, and this dot bold right here matches this class equals bold. And so because those two things match the same tag, it only gets included once.
Why is the answer 4 for number 3?
So for number 3, there's this P tag right here, this P tag right here, this span class equals bold, and this span class equals bold. In this case, we don't have any sort of like nested tags going on, but if I change this from class equals italic right here to class equals bold, then we would return both this P tag and this span tag. Even though the span tag is inside of the P tag, we would return both of them. And I think the other practice quiz, the second practice quiz has examples with that. Good questions. Any other questions about this? I think this is maybe the key important difference to take away from today. But I think that'll be where people miss the most points on the quiz, and again have get stuck in different spots on the homework. Good. Sorry, can you say that again?
To be clear, it's just that they're creating 2 separate lists when you select them. You just add two separate lists.
Exactly. So soup.select just returns a list, like a regular ordinary Python list, and the addition right here is just ordinary Python list addition, which doesn't remove the duplicates. Exactly correct. Then, so number 4 right here. So number 4 is the main idea that's going on here is that here when we have tags equals soup.select of P, so this tag's right here, then we're going to iterate over those tags and we'll call tag.select on A on side each of these P tags. And so it's gonna walk through this here step by step about what's gonna go on. So say tags equals soup.select P, look at the tags. We get two different elements, 2 different P tags. And then inside each of these P tags, I'm gonna look for A tags that are inside of those P tags. So tags, say tag equals tags 0, and then tag.select A. There's nothing inside of the very first tag. The only thing that's inside of it is this span. But inside of the second tag, so tag equals tags at position 1, tag.select A like this, finds the A tag that's inside of this P tag right here. The key idea of this problem is that it's not only the soup object that you can do the select on. You can do the select on any of the different tags, any of the results of a previous select. And it works sort of how you might expect, that it'll find it as a sort of sub tag of this tag right here. This sort of structure here is very similar to the structure of soup.select P space A that we had sort of right here, where this A is going to be a descendant of this P. Here, this A right here, we're doing tag.select inside of tag, where tag corresponds to one of these P tags. So we're looking for A's that are descendants of P's. And so what's happening in this problem is that it's basically, this is a sort of a really long-winded way of just writing P space A as your selector. That anytime you have this selector where it's just a space, then it's internally doing something that looks like this. Equivalent to soup.select P space A. Yeah, there's a fair bit going on here. So if you have questions, that's totally okay. And now would be the time to ask. Is there any questions about that? Yeah,
Can you
please.
go through what you're doing with like tags and tags 0 or tags 1, just like a little bit slower?
Sure. So what I did right here, I started with tags equals soup.select p. And so here is the tags variable as a list. And then I was sort of simulating this for loop right here of assigning the tag variable to each of the elements inside of the tags list. Sort of like would happen in Python Tutor, but we can't use Python Tutor for this problem. And so I did that by saying the tag variable equals tags at position 0 like this. So that's sort of like the first iteration of this for loop. What is tag going to be equal to? And then we can see that tag is this p tag right here. And so if I did that tag dot select an a, then there is no a tag inside of here. There's only this span tag, so we get nothing back. If I were to change that to span, then I'd get this span tag right here that matches this span tag right here. And that's the first for loop, looking for the a here. And then the second for loop, second iteration through the for loop, I said tag equals tags at position 1. And then let's take a look at that tag. So now it's the second p with the class equals bold. It has an a tag inside of it. And so when I do tag dot select a, it's going to get that particular a tag right here. It's important that this is the tag.select a and not the soup.select a. If I did soup.select a, it would get multiple a tags because there are other a tags that do not exist inside of this p tag right here. Good question. Any other questions about this problem? Exactly. This tag right here is each of these tags in this variable found by this soup.select. So it's all the p's in the document. So there's a lot of different ways that we could have done something like this. So here, your suggestion was, I think, tags.select of a like this. And if we did this, we'll get this attribute error because tags over here is a list. And so we want to do the dot select on the entries inside of the list and not on the list itself. We could have done something like anytime you're sort of tempted to do a function on a list, the thing that is the right way of doing that is the list comprehension. So we could have done something like tag.select of a for tag and tags like that. And that's, I guess that's not exactly what the accumulator up here is, but that's the closest analog to what you were suggesting. Let's see, since we're talking about list comprehensions down here, there's one last problem down here. This problem, I've called it extra because it's not something, you're not going to have a problem like this on the quiz, but this pattern inside of this on this line right here is potentially a really useful one for you in your homework assignment. That here, what I'm doing is, so this tags equals soup.select star. So again, if you have the star, that means match everything. So now this basically is all of the HTML tags. So let's see how many tags are there in the document. There's 17 of them. And then what we wanted to do is sort of filter them to see if the tag contains a certain piece of text. So again, this dot text on a tag just gives you everything that's the contents between the tag. So if we have tags at position 0, that's actually our HTML tag. Tags at position 0 dot text is all the actual text of the document with all the tags removed. Tags at position 1 is the head tag. Dot text is just the lorem ipsum from this title right here. All the stuff outside of HTML tags. And this list comprehension, what it's doing is there's no computation going over here, so it's just returning the plain tag itself. But there's an if statement here, so it's filtering it, just checking to see, is lorem ipsum contained in the text anywhere? And, whoops. Go ahead and copy and paste that down here. And if we do tags filtered, this contains now all of the tags that contain the text lorem ipsum somewhere inside of it. And so I want to come up here to our HTML here just to look at where is what tags contain lorem ipsum. So it's just, this is the only spot in the text that contains this lorem ipsum phrase. It's a little bit maybe confusing because here up in the title, it's also lorem ipsum, but again, Python's case sensitive, so this capital I doesn't match. So it's only this down here. And then what it's doing is that, so this span tag contains the lorem ipsum, this p tag contains the lorem ipsum, the body tag contains the p tag, so the body tag also contains lorem ipsum, and the HTML tag contains the body, contains the p, contains the span, so it also contains lorem ipsum. So there's, it's just, so those are the 4 tags that it's returning: this span, this p, this body, and this HTML. And again, what's happening down here when we do the select with star, star means find everything. And then we're filtering it so that the text doesn't contain, or so that the text must contain lorem ipsum. You're not going to have a problem like this on the quiz because, so specifically a problem involving the text attribute here, just because there's a lot of text up here and I don't want you to have to like try to scan through all of this text finding things. But this is still an important sort of combination of our list comprehension patterns and this idea of what the text attribute does for Beautiful Soup.
So you get 4 for this. When I'm trying to explain. You receive the tags that count. It's like all of the tags that are nested.
That's exactly correct. Yes. So whenever you have the star means find every possible tag. So here, let's do some examples real quick of the star. So I'm gonna move our screen up here to the HTML so we can look at the HTML while we do this. And if we do soup.select star, and let's just look at the length of this. There we go. Length of soup.select star 17, because there's 17 tags. It finds all the tags, all of them, whether they're nested within each other, whether they're self-closing tags, doesn't matter. It finds all the different tags. And so where this gets maybe a little bit complicated is where we have more complicated CSS selectors. So if we had p space star like this, let's try body space star. Then it's first going to find the body tag, and then it's going to find all the tags contained inside of the body tag. So body space star is different than just body. Just body by itself would be just this tag here. Body space star gives everything down here like this. If we did the body then the greater than star, remember that the greater than sign is it must be a child and not just a descendant. So here, body greater than star finds this div, this h1, this p, this block quote, this p, this br, this a. And so it finds those 7 tags, but it does not find, for example, the span tags that are descendants but not children.
So meaning that will create.
I'm not sure what you mean by the verb create.
So for example, so it's looking for every possible
Star finds every possible tag that matches whatever's to the left of it.
Right. So for example, hat, let's say that it contains lorem inside the title, which is inside the hat, and then it's going to select title, which also contains lorem.
So if we,
There's going to be 2 of them.
sorry, you're saying the
Hat.
hat, H-A-T?
H-E-A-D.
Head, okay. So head space star, head is right here, title is the only descendant, and so we get 1.
No, I'm talking about the original one, when we're selecting everything.
So just star.
Just start this. So, and then we're only counting those who have lorem ipsum.
Yeah, so this right here finds everything, and then this part right here filters it, removing the things that do not contain lorem ipsum.
Right. So for hat, that is considered one of them that contains it.
In the head tag, there is not anything that contains it because it's case sensitive. So up here, it's a capital I, down here, it's a lowercase I. So this one does not match. So if we come down here and just, I'm going to copy and paste this and take a look at the tags underscore filtered. There's a lot here to look at, but there is no head tag inside of here.
Can you show the tags again, the 4 tags?
Sorry, which 4 tags?
What are the lorem ipsum, the extra solutions, 4 tags that are counted?
So here's the lorem ipsum right here.
Yeah.
It gets this span tag, this p tag, this body tag, and this HTML tag. Is there a question, Miles? Or no? Okay. Yeah, so again, if there's any, if you don't feel perfectly comfortable with this, that's okay. This is just a pattern that you might find useful on your homework assignments. Again, not even required to use it on your homework assignment. And it's not going to appear on the quiz. That only problems similar to these 5 up here are going to appear on the quiz. And then the last thing about this quiz, I didn't say this yet, but because this is also testing your CSS selector knowledge, if you get a better score on this quiz than your CSS selector quiz, the very first quiz, it'll replace that score. And then there's the other practice quiz 2 has a whole bunch of different example problems that you can try out, make sure that you understand all of your different CSS selectors. Any questions on anything Beautiful Soup related? Please.
This is a really basic question, but I didn't really understand it when you explained it in lecture on Monday. But Beautiful Soup is a library of selectors that you use on HTML, correct? Or like what is it?
Sure, yeah, so Beautiful Soup is the name of this Python library that lets you use CSS selectors to extract things from HTML. So I think of it as sort of similar to the JSON library in Python, that JSON lets us extract information from JSON formatted text documents. Beautiful Soup lets us extract information from HTML formatted text documents. And these idea of CSS selectors, this is sort of like a common principle for all programming languages. So whether you're in Python or any other programming language, there are libraries that use CSS selectors. So that's not unique to Beautiful Soup, but Beautiful Soup is Python's interface to that. Did that clarify? Okay, then, so the rest of today and this week, we're going to be talking a little bit more about debugging skills and how to get, be more efficient with your debugging and figure out what the exact problems in your code are. And there's a handful of references down here that go into a lot more detail than the stuff that we're going to talk about in class. So if you're wanting to dig into even more stuff, you can reference this, but you don't need to. We're going to start by taking a look at each of, let's see. Sorry. There's these 8 different types of exceptions down here, and we've encountered all of these in class so far, but we're going to take a little bit more careful look at the different causes of these 8 different error messages. And if we had the printouts today, I was going to just start by going through the actual practice quizzes, but instead we're going to go through VS Code. And before going through VS Code, I want to just take a look at these practice quizzes just so you can see what the format is, so that you have an idea of like what to expect for, I guess, the motivation for why we're doing what we're doing. In this practice quiz, there's 2 parts to all of these problems. The problem first asks like basically whether there's an error in the code. And there's going to be 2 types of error messages. So throws an exception. An example of something that throws an exception would be if we're down here and we did something like hello +5. This is an example of an exception. This is the type error exception, and we're going to talk in more detail about all these different exceptions that we've been seeing and how to handle them here in a second. But this is an example of an exception. And then the other sort of error is the runs forever, so the infinite loop problem. And we had this, talked about this a long time ago when we were talking about while loops. And so on this quiz, if there's a while loop, you might possibly, not necessarily, but might possibly be in this runs forever situation. But if there's no while loop anywhere, so something like this, there's no while loop here, then you can just know instantly off the bat that you're never going to be running forever because there's no while loop. Similarly, if there's a for loop, if there's a for loop, you would know that you can't run forever. That's the advantage of a for loop over a while loop. Can't run forever. You can only do the runs forever if there's a while loop. And then on the quiz, if it does throw an exception, you have to be able to tell me what exactly is the exception that it threw. So there's these 8 different exceptions that we're working with. These 8 different ones down here. And you'll have to, for the quiz, really understand all the subtle differences between all of these different exceptions. And know that if your code is misbehaving in a certain way, is that a name error or is that a type error? And this is an example of one of the quizzes that is new this year, not in previous years, because I've just found that students often get a lot of misperceptions or confusions about exactly what all these are doing. And so I wanted to take some time to just really clarify exactly the differences between all of these things. And that's what we're going to do next. I just wanted to show you the quiz so you have an idea of like where we're going to be applying this in practice towards your grade. Where's VS Code? There it is. I'm going to open up, there's a file. Where is my file? Well, I'm not sure. Oh, exceptions.py. There we go. I may have forgotten to highlight that one as one from GitHub that you should download, but that's what we're going to go over to see, that defines exactly what all of these different error messages are and shows you examples of things that are and are not examples of each of these error messages. So this exceptions.py file is what we're going to go over next. The very first of these, let's see, in the exceptions.py file, I've ordered them from easiest to hardest. And on the README file, I've just ordered them alphabetically. So we're going through them in a slightly different order, but this is the easiest to hardest order here. And the first one here is this zero division error. Basically, what causes a zero division error is when you divide by 0. So if we have 12 divided by 0, you can see that we get the zero division error down here. And this exception always appears on the very bottom line of your error messages down here to the left of the colon. So this right here is the exception. The thing to the right of the colon is just a longer explanation about what the particular cause of this exception is. And anytime you have any of the different types of division operations in Python, so the regular floating point division or the integer division, or even the remainder division, this can cause the division by 0 error. And it doesn't matter what your 0 is over here, whether it's an integer or a floating point number, it can still cause it. I think most people find these examples pretty intuitive as problems, but this one's maybe a little bit surprising to people, or if you think about it, it makes sense, but maybe not one that you would have guessed originally. So if you have the %, then you can get this division by 0 error as well. Any questions about that error message? So the assertion error is one that we're going to start encountering here really soon, but we haven't, I don't think, seen this one yet. And the assertion error is, it's also a relatively easy one though. Here we have assert, and then if whatever is inside is falsy, so like assert false, that's falsy, we get this assertion error down here. But if whatever I have inside here is true, or truthy, then we get no error message. The assertion error is commonly used, or this assert function is commonly used when you're defining functions. So let's see. Get the remainder and a comma b, and we might do something like assert b is greater than 0, and then return a %b. And so anytime our function has some sort of like preconditions that it must satisfy, it's common to use the assert right here just to enforce those preconditions. We haven't seen this yet, but we're going to start seeing this with our next homework assignments. So we're going to start encountering this. But at this point, you just need to know, you don't need to know the why necessarily, just that anytime you have something truthy inside, it'll be no error, something falsy will give you an error.
Sorry, can you explain again? So it's because there's nothing inside the bracket.
Exactly, so the square bracket here is falsy. Empty list is falsy. Any list with any contents is truthy. Yeah.
So when you're doing that, when you do the same thing that you did, so you're just not going to return anything until you do assertion error if it's less than 0.
Exactly. So let's go ahead and create this function down here. So get the remainder of 10, 3. It gives me, actually computes this right here, checks that b is greater than 0, and that works. And so this line does nothing right here and just comes down to this line right here. If we change this so that it was a 0, then we'd get that assertion error right here. Ready? So what assert does is it's a function that takes a parameter, and all it does, the only thing that it does is that it raises an assertion error if the parameter is falsy. Exactly, it's like an if statement of if this thing is false inside of here, then panic and barf out an error message. If it's true, then do nothing. Yeah, so again, if the purpose of this function seems weird, that's okay. All you have to know is you just check, is the thing inside true or false? And then if it's false, you'd get the assertion error. The next one is the attribute error, which is one that we've encountered quite a lot. And I think we want to be a little bit more, I guess, careful about exactly now what is the cause of the attribute error. So whenever we have this dot syntax of like, so as an example, xs equals 1, 2, 3, and then xs dot append 4. This xs over here corresponds to this object right here. This append right here corresponds to this function. And anything to the right of a dot in Python is technically called an attribute. And so an attribute error is when the thing to the right of the dot doesn't make sense to the thing to the left of the dot. So here, the replace function, replace makes sense for strings, but it doesn't make sense for lists. And so if you do that, you get an attribute error. List object has no attribute replace. Similarly, the append makes sense for lists, but it doesn't make sense for strings. So you get this attribute error when this happens. Are there any questions about the attribute error?
I think this might be a more general question, but when there are like two errors in one thing, does it always read the first error or does it list all of them?
It's a great question. The question is, what happens when there are two error messages at once? And let's go ahead and let's see. At this point, we're not ready actually to talk about that. Once we see all of these examples of errors, then we'll see that. We'll see examples of that. The short answer is Python will only print out the first error that it gets to, but it'll be a little bit confusing about which error is the first one. This next two error messages, index error and key error, common ones that have come up for people, and they're closely related. So here, the index error can only happen on a list, and the key error can only happen on a dictionary. And they both happen when you use the square brackets incorrectly. So the index error up here, xs at 3, because let's go ahead and redefine xs again. Xs at position 3 gives us the index error because position 3 does not exist inside of this list. The key error happens on the dictionary. So if we define this dictionary, and then d at created at like this, we get the key error instead of the index error. And again, the reason for that is just that for lists, the thing inside the square brackets is technically called an index, and for dictionaries, the thing inside the square brackets is technically called a key. So that's why it has two different error messages. But anytime you see one of these error messages, you should just double check in your mind, like, was I actually expecting a key error here? Was it a dictionary that I was indexing into, or should it have been an index error? Did I think it was going to be a list? Any questions about the difference between index error and key error?
So because there was no created at key, it would change the key error.
Exactly.
Same thing.
Maybe the question, is there like a value error or the value?
Good question. So there is something called a value error, but it happens to be totally unrelated to this. So confusingly named. So value error is something you don't have to know, and basically this is the catch-all, like. If it doesn't fall into one of the other categories of errors, then it's a value error. Okay, these next two of name error and unbound local error are, again, they're both obvious and confusing at the same time. So the name error here, anytime in Python, you just type out something that doesn't exist. So like example, I've never created a variable example, so I get the name error. Name example is not defined. The most common way that, that this happens, that you get this error message, is that if you have some sort of maybe dictionary, and instead of doing D square bracket text like that, you leave out those quotation marks, and you get the name error here because the name text is not defined. So here it's thinking that text is supposed to be a variable. It's looking for what is the variable that we substitute here. There is no variable that we substitute here, and so we get that error message. If we were to say something like, so let's go up to the, so here's example, gives us the error message, example is not defined. We can get rid of that error message by just defining example. Example equals 5. And now when I type example, we just get the number 5. When I have the D at position text, we get this name error right here because text is not defined. I can fix this by saying something like text equals hello, like this. And now when I do D at position text, we'll get that key error because hello is not a key inside of this dictionary here. So this is, yeah, I'd say one of the most common sources of bugs or of these error messages is just forgetting to include the quotation marks around your dictionary keys. And then, so this name error and this unbound local error, they're exactly the same thing, except that unbound local error happens inside of functions. So here I've created this function, and we have this, this variable here. I'm gonna, since I've already defined example down here, let's change this to new example. When I copy and paste this right here. And the first thing that you'll notice is that when I define this function down here, I do not get an error message. This new example here does not exist, so it doesn't make sense to do a plus equals 1 to it, because again, plus equals 1 is equals new examples plus 1. So we can't add 1 to it, but this doesn't throw an error message until I actually call the foo function. So now when I call foo like this, then I get this unbound local error. So unbound local happens inside of functions. The name error happens when you're outside of functions. Otherwise, they're exactly the same thing. In this class, the most common way that the unbound local error comes up is when you're working on like the doc tests, actual test cases. And when you're working on a bigger project, so not working on the doc tests, then you'll get the name error. Any questions about the difference between those? Okay, and then the last one is the most confusing one. And this type error has examples that relate to all of the previous things that we've talked about. So the first example of a type error is relatively simple, that it's just, we have say like string plus integer. We've seen this before. That gives me my type error. You can't add these two things together. But if you want to add them together, you have to convert them to the same type, and then you can add them together. There are certain types that you can do math operations on. So like adding integers to floating points. Python automatically converts the integers to floating points for you. So this works. And then we mentioned this in passing a long time ago, but haven't seen any more examples of this recently. But you can actually multiply numbers times strings in Python, and it just repeats that string that many times. So that's an example of something that's okay. That's an example of something that's not okay. So it's an easy thing to get confused on the quiz. It's a good one to pay attention to. The difference between string times a number and string plus a number. And with this times, it also does not make sense to multiply by a floating point number, because what would it mean to like have it 40.5 x's? What's a 0.5x? That doesn't make sense. So you get that type error here of this multiplication. And so this is I think a pretty straightforward example of the type error. The length one's also pretty straightforward. So if we have like x equals 5 down here and we take the length of x, that doesn't make sense. That we can do a length of a list, that makes sense. We can do the length of a dictionary, that makes sense to do, but the length of a number does not make sense to do. This one down here, though, is where it's easy to get confused on the quiz. So this is another like good spot to pay attention and how it relates to the previous error messages. So let's say I have, again, an integer, and we try to subscript the integer. So it doesn't make sense when you have an integer to subscript it by anything, so you'll get this type error. But also if you have a list, so lists, it does make sense to subscript by, so we can do XS at position 0 gives me the 1, XS at position 10 gives me the index error, but XS at, say, test gives me a type error. So index error on a list, if your index is actually out of range, that you had a number, passing in a number here, and the number is just too big or too small. For if you pass in anything other than a number, though, then you get the type error, because only a dictionary can have the square brackets with something that is not a number, and a list is not a dictionary. So that's why we get the type error right here. Eddie?
For the math operation, in order from 4 plus 0.44, I have to find like the null plus 0.4.
Just 4 plus 0.4 should work. Mm-hmm. Yeah, so Python automatically converts these integers to floating point numbers for you.
Also, so for container type, what would the container type be? Strings, lists, or dictionaries?
Yeah, so the question is, what are the like container types that that we're working with so far? And so example, containers, so the string, the list, the dictionary, those are by far the most common that you might do these operations on. But the range is also technically a container type. We've seen that enumerate function that returns a container type as well. And so all of these things, anything that you can sort of convert into a list somehow, that you can call list onto, is technically a container in Python, and that you'd be able to do the length of. Certainly on a quiz though, I'm not going to go into like these more exotic types. It'll just be strings, lists, and dictionaries. So there are lots of other error messages. We've seen lots of other error messages before, but these are the ones that you're going to be required to know exactly what are their causes and how to fix them. Any questions on any of these 8 exceptions before we move on?
Could you explain the name error again?
Yeah. So the question is about the name error. And the name error just happens anytime you reference a Python variable that has not been defined yet. So like basically not to the left of an equal sign. So here, if we create a something like variable or variable plus 5, this doesn't exist yet. variable doesn't exist, so we get the name error. We can fix it by saying variable equals something, and then it works. And then the name error happens when you're not inside of a function. So these are not inside of a function. The unbound local error happens when you are inside of a function.
And then for the type error, I'm just curious as to why the 4 plus or the string x times 40. Why is that allowed?
Yeah. So the question is, why is this allowed in Python?
Yeah.
And personally, I think it's a very ugly thing. I think, yeah, I don't know, I find that hideous that you can multiply a string by a number. But Guido, our BFDL, thinks that was beautiful, and so when he was first writing Python 30 years ago, that was one of the first features he added to it. And once it's been added into Python, people start using it, so you can't take it away. I think a lot of people wish that we could take that away, just because it's so weird. So not a good reason, but that's it. Yeah.
So if you say like string equals and then like x, and then the next line is x times 40, that just returns, like, because does it stand by the fact that like you can't manipulate strings, and so it returns the same x, or would it?
Is it?
Yeah.
So here s stays the same, and this is not actually like it's not modifying x, it's just creating a new string that has that result.
So it's still, it returns the original function and then creates a new string, which is s times 40.
Exactly.
Okay.
Yep.
I have a question related to this, but general question.
Okay.
So how was Python written? Like, did he use some other language to write Python in?
Yeah, it's a good question. So the question is, so basically, how do you write Python, or more broadly, how do you write a programming language? And so back in the early 90s, when Guido was working on creating Python in the beginning, and Python started off being written in the C programming language. Since then, it has evolved, and it's written in several different programming languages. My favorite implementation is actually there are Python versions written in Python. We call it self-hosting, once you can write a programming language in its own language. And that's, yeah, we're not CS majors here, but if you were and you went on to take a compilers class, that would be like the ultimate goal of the compilers class, is how do you write a programming language that can write itself, so that you now only need that programming language. Like if all the knowledge in the world disappeared, but you still had that programming language, you could still keep doing things. Yeah, let's see. That's the short answer to that question. But good question. Any other questions so far? Good questions. Let's see, we're almost at the end of time today. So we'll start getting into the really interesting examples of these exceptions, but we won't quite finish the interesting examples today. We'll get to that on Wednesday. And so I want to see here, we've seen lots of examples of things that cause bad error messages in the past. So like if we have a URL that's a bad URL and calling request.get on it, we get some really ugly sort of error message like this. This whole thing out here, this whole output in Python is called the traceback. The general term for a traceback in programming languages is called a stack trace. So people use those terms interchangeably in Python. Traceback equals stack trace. And I try when I'm working with Python to always use the Python specific terms like traceback, but I might say the word stack trace sometimes too, and they're just totally synonyms from each other. And what this is so down here again, we can see that there's this error message down here, this missing schema error message. But the question is, how do we figure out like where in our code does this error message come from? And up here we see there's a bunch of different file names, and these are all actually files that are included in the requests module. So this error message is happening on line 388, somewhere in the models.py of the requests module. In order to find out where in my own code this is happening, you have to keep scrolling up until you find your actual file name. Since I typed this in interactive Python, there's no file name in here. So I'm going to redo this by actually making the error message happen up here in my Python code. Coming down here and rerunning this. Whoops, that's the wrong one. Do the triangle button. And now we get that same error message, but now if we keep walking up here, we'll see eventually we get to a line that has my file name in it right here, and then it shows the line number that it happened on my particular file. Right now, this is commonly going to be the very top line of the stack trace or the bottom line of the stack trace, but we'll be seeing more examples where it's buried in the middle here, and it'll be a little bit harder to find. But so you see here, line 120, line 120. Let's see, that's all the time that we have today. I'm happy to stick around and answer questions, but otherwise, I will see you all on Wednesday. Again, we'll have the actual quiz on Wednesday, and I'll hopefully have printouts for you of this quiz, and we'll continue on with these more detailed debugging techniques.
Wednesday is the quiz we supposed to have last Monday.
Exactly. So Wednesday is the quiz we were supposed to have last Monday, which is the list comprehensions quiz on Wednesday. The beautiful soup quiz will be a week from today, next Monday. Yeah. Kevin. Why are all these other things here? Basically, each one of these lines corresponds to an individual function, and when you call this, it actually is calling all of these functions. So we'll see in detail next time what all that corresponds to. Okay.
So for the actual practice, the last one. So my question was that we're looking for every time, right? We're looking for every time first, yeah, and we're looking for tags that contains lower ipsum with the I with lowercase, right? So the first one is this considered contained?
If it was spelled correctly, it would, but it's spelled correctly.
So okay, so let's assume this one is lowercase then. Because I just want to example. Would these two duplicate?
So it would get title, head, and HTML for that.
So head, title, both. Oh, HTML, head, and title. They all duplicate together.
Yeah.
Gotcha. And these goes the same to H1, span. And then H1 again? No. H1 is spam. Oh no, these are not the same.
So here you would not get the spam, you would get the H1. Because H1 contains more, and if some,
if it's a lowercase.
Mm-hmm.
Gotcha. Thank you very much.
I just have a quick clarification. Are we also because that's still counts?
Sure.
I had a question on this is like lab 6, part 1.
Okay.
On that one, I had done what I thought was the edit, but I don't think it counted. Like, can you just tell me why? Because here's my
You run the output.
Yeah. Like the ones where I had to justify it to the side, and then the lesson is the 0.
I see. Can you explain why you chose the number 960?
Because it's all the way on the side, and I didn't actually. I was trying to do that, but like by justification. That's the
I see.
best way I found.
I think probably the number was just so big that I didn't realize that it was.
Okay,
Yeah,
maybe it just
so-
looked on my screen. So
Uh,
it was English.
Yeah, so you get the credit. Let me adjust this here.